I'm Peter Chin. You've seen me in such fine quality chemistry educational videos as Percentage Composition in Chemistry, The Connection, and There's a Percentage in Chemistry? Today we are going to be looking at the percentage composition of different compounds. Okay, I'm going to work through two examples with you guys, examples that one of those we've used in our lab recently, and another one that we have worked a lot with in class. Now, what do we mean by percentage? Well, percentage, remember, it's part over the whole. That would be a fairly important thing. So if you were to go take a test, the test is worth 100 points, you scored 85 out of the 100, you got part, the 85 over the whole, which is 100 or 85%. Okay, now the part over whole is one thing that does not give you a percentage, because you will have to multiply whatever that part over the whole is, because that will be a decimal. You have to multiply it by 100 in order for it to work out as a percent. So here we're going to look at NH3 ammonia, and here we have percent nitrogen and percent hydrogen. Well, we need to look at how many grams there are in a mole, because when we look at the percentage, we're looking at percentage by mass. So the percentage, all the mass of the nitrogen compared to the mass of our ammonia, all the percentage of the 3 hydrogens compared to the mass of the ammonia. And that's what we have here. We're going with nitrogen being 14.01 grams per mole, hydrogen being 1.01 grams per mole. So here we have 14.01 grams per mole divided by 17.04 grams per mole, and that's the grams per mole for nitrogen over the grams per mole of NH3. If you're not following on the grams per mole, I would suggest you look at a previous video in stoichiometry that covers how to calculate the grams per mole. So here's our part, here's our whole. We divide that, we get 0.822, but we have to multiply by 100, which is what I did here in red, and we have 82.2% nitrogen. That's it. Now, what about the hydrogen? Well, we've got 3 hydrogens in there, 3 hydrogens in the thing. Are we taking into account all 3 hydrogens or just one of the hydrogens? No, we're taking into account the 3 hydrogens that are there, which means that we have to add all those hydrogens up. So instead of 1.01, which is for 1 hydrogen, we're going to have to go 3.03, which is the 3 hydrogens all told. So this is what we have here, 3.03 divided by 17.04, and we get 0.178. That's our decimal. Now we can multiply that by 100, which I did in green, and the final answer, ladies and gentlemen, is going to be 17.8% hydrogen. So when we look by mass, the percentage composition of ammonia, 82.2% of it is made up of nitrogen, and 17.8% of it is made up by hydrogen. Yeah, like that. So let's go ahead, let's pick one that's a little bit more complicated. Here we got sodium carbonate. This is the solid product you would have left if you took baking soda and you were to heat it up. That reaction, you'd get rid of water, it will go bye-bye. Carbon dioxide will also go bye-bye, so they both go bye-bye, and what you have left is Na2CO3, or sodium carbonate. That's sodium carbonate. So here are our grams per mole for the sodium, the carbon, and the oxygen, all told. Okay, so let's look at our percentage of oxygen here. Okay, well, there's 3 oxygens. Remember, you have to take into account all of them. So there's 3 oxygens. You have to take into account all of them. So it's going to be 3 times 16, or 48. Okay, so that's our part. Here's our whole, which again we calculated over here. This is our whole. We took our 2 sodiums. Okay, so here's a sodium. Here's another sodium. So these are our 2 sodiums. Here's our carbon, and here's our oxygens, our 3 oxygens. So we added all of them up to get 105.99, or really, really super close to 106. So that's what we did. Then we proceeded, whoa, that's a little tricky. Then, okay, it's not gonna let me do that. I gotta do it on the other side. Then I go ahead and say, okay, we're gonna take the 48 grams of oxygen over the 105.99 equals 0.45. We multiply that 0.45 because that's not our percentage, that's just giving us a decimal, times 100, and we got 45% oxygen by weight. Okay, well, what about the carbon? Well, we got one carbon in the formula, and that's 12.01 grams per mole. And we're going to take that and divide it by how many grams there are in a mole of Na2CO3, or sodium carbonate. We divide that out and we get 0.11, okay, which if you multiply by 100 gives us 11% carbon. Yeah. Now, for our final one, the sodium, there's two ways we can look at it. One way, we can go ahead and take our remaining mass of sodium, which is 22.99 or close to 23. You multiply by 2, you get 45.98. Because remember, it's not about one sodium, it's about the two sodiums in the formula. So we got 45.98 over 105.99 grams per mole. So we end up getting about 0.434, which is kind of close to 44. You're not always going to have all the percentages add up to 100. And the reason for that, if you look at the grams per mole of the individual elements, remember that they are averages. They're not exact, because not all oxygen's atoms weigh exactly the same, which is true for the sodium atoms, which is also true for the carbon atoms, and so on and so forth. So when we work with numbers from the periodic table, we're really looking at the average of them. And that's what the chemists have figured out. So in this case here, guys, when we look at it, it's about 0.44, or the percentage of sodium is about 44%. Now that's one way to calculate it. Another way to calculate it is you add your carbon, percent of your carbon, the percent of your oxygen together, and subtract it from 100, and you would get your percent of sodium. Now, one way you can check to see if this is right, you can add the 44% plus the 11% plus the 45% to see if it adds up to 100. Okay? Now we can also do the same thing with here, going back to the ammonia. We can take the 17.8%, add it to the 82.2% to see if it comes out to 100%, which it actually does. So, there you have it. This is calculating the percentage composition by mass of any compound that you have. You're going to take the part of the element, like all the hydrogens, for example, and divide it by the total grams per mole of the compound that those hydrogens are involved with. And don't forget to multiply by the 100, or move 2 decimal places to the right. I'm Peter Chen. I'm hoping that this helped you guys out. You take care and have an awesome day.